Hello everybody and welcome to the latest Chem webinar. Good morning, good afternoon or good evening wherever you are in the world. My name is Kate McKim and I'm the Marketing Executive here at Chem. The title of today's webinar is Using Predictive Data in Standardized Testing in Tracking and Monitoring. And so I'm delighted to be joined today by Jonathan Allday. Jonathan has worked as a teacher, a subject head, faculty head and academic deputy at several boarding and day schools across the UK. He's mostly known for his work on the steering group of the HMCPD Academic Deputies National Conference, which he has chaired twice. In June last year, he retired and he is now working as a consultant, offering his experience of chem data, curriculum development, timetabling and management, etc. to schools. So today, Jonathan will be covering the role and limitations of predictive data, predictive grades versus chances graphs, from baseline test to public examination outcome, reporting on progress, evaluating benchmark tests and standardizing test results, avoiding bureaucracy and creating a culture to encourage progress. So you're all in listen only mode at the moment. So if you could please submit any questions or comments in the questions box, which is located in the control panel. Questions and comments are welcome throughout the entire presentation. We'll either pick up on these convenient time during the presentation or during the question and answer session at the end. You'll also receive a certificate of attendance via email. You'll receive this 1 hour after the webinar finishes. So without further delay, I'll hand over to you, Jonathan.
Hi, and let me just add my greetings from what is a cold Yorkshire in the UK. It's some implausible hour of the morning here, but it's a pleasure to be with you, and thank you all for tuning in. I'm going to switch my webcam off in a second because you don't want to see my mush while this is going on, and also because it probably helps a little bit to make sure that the audio quality and the signal of the important thing, which is the presentation, is going on. I became an academic deputy an implausible number of years ago now, probably nearly about 20 odd years ago, and I certainly remember walking into my new redecorated office as I walked in, and the shelves were completely lined with huge thick ring binders of chem data, because the school where I was working had been part of the chem process way back till about 1979, I think. And I don't know whether I was particularly impressed by these racks and racks and racks of chem folders there, as much because they were there, so they were clearly not being used. And certainly at my previous school, we'd engaged with chem data as well. And as a head of department and as a head of faculty, I've been given the value-added feedback to do with my departments, working in the science department. And I was just sort of chucked these printouts in an envelope and said, there you are. I'm not really given any guide as to what to do with them, what they meant, anything like that. And it was very interesting then sitting on the other side of the fence, as it were, being the person chucking this data out to the heads of department rather than being the person on the receiving end. I'm going to talk a little bit about that sort of thing during the course of this presentation. Forgive me, by the way, I've got my mobile in my hand. It's not that I'm already bored and want to text anybody. I'm actually using this to control the presentation. Well, at least I hope I'm going to be. So let's see how that goes. I'm going to switch off my webcam now, and let's make a start on the actual presentation itself. Now, one of the things that would be actually quite interesting to know, and we might put this into a poll subsequently, but we should have thought to have done it before, is how many of you actually out there already use chem data and have used it for some while. What I want to do at the beginning, at least, is to just do a little bit of a skate through what the chem data is and what it gives you, at least from my perspective. Many of you may know the technical side, or at least know all about chem data already, but I'm going to put my own personal spin on it for what that's worth, possibly giving a little bit of experience of having used this, as I said, for many, many years. And I would suggest that there is a sort of basic premise at work here, which is going to underpin the whole of this presentation. And I hope it's a reasonable premise that you'll all agree with, but I'm going to defend it just quickly now, which is that using a baseline data to set a realistic, whatever you might call it, and we went through several different variations at schools where I've worked at until we got to this idea of a challenge grade for pupils. And if you follow that up by some effective way of tracking progress within your cohort, they're working towards some sort of challenge grade that you have set them, an aspirational grade of what their eventual achievement in a public examination, for example, might be. And you then track their progress towards that. You have good teacher interventions. You have some sort of focus on exam requirements, developing exam skills, what the keywords mean, how they should go about constructing answers, reinforcing the grade requirements. There's a degree of overlap between those two, obviously. All of these things working together help to raise pupil attainment. That's my premise. Why do we want to do this? In the end, we want to do this to raise attainment. But, and there is quite a big but to this, how should that grade, challenge grade, target grade, baseline grade, whatever you call it, I'm going to use challenge grade throughout this presentation. How should that grade be derived, validated, and approved? Where does it come from? And how should that progress towards that grade be monitored effectively? And here is where, in both of those, answering both of those questions, I think that the Chem data has a role. Now, as it happens, my understanding of the history of Chem data is that it was originally set up as being a research project looking into value added. Now, what does that mean? Where do we get value added from? The idea here is if you give a collection of pupils up and down the country, or indeed across multiple countries, basically the same test, roughly the same age, and you can use that information to statistically, we'll talk about how shortly, predict some GCSE grades or whatever public examinations or whatever level we're talking about. And then you sit back and you wait a few years, and you then collect their results, their actual results, rather than their predicted results, and you make some comparison of the predictions with reality, then that is the premise. The difference is because all of these pupils, a particular pupil with a particular baseline score, whichever context they find themselves in, whichever school, whichever country, whichever environment, they have the same basic ability, at least as measured by that test. Then what has made the difference between that baseline ability and that ultimate public examination? That is the value added. And the inference, the supposition is that on average, individuals, different fluctuations due to personal circumstances, aptitudes, that sort of thing. But on average, what makes the difference is the input provided by the school, provided by the teacher. So to flesh that out a little bit more, you have a group of students take this baseline test, and they have a score which is somewhere in a scale between what you might call low, what you might call average, and what you might call high. And as we know, in the case of Chem, the scores are standardized to 100 being the average for the sort of national scale. And then you have their outcome grades, which will be their, shall we say, GCSE in the UK scores. And if we were to plot that as a chart, you get something that looks like this. Now, it's got this curious stripy effect to it, because while the baseline score can be any value, typically between high 80s and 130, maybe something like that, can be any numerical value, the grade can't be. Obviously, it's either got to be A, B, C, D, E, or 1 to 9, like that. So you get this curious stripy effect. Each of these stars on my chart here is supposed to represent an individual pupil, or more likely a collection of pupils, because there'll be a lot of data in such a chart. Well, most of the data lies within a region outlined sort of like that. That's where most of the scores, pupils, and outcome grades are going to be. So what the magicians at Chem do is they do a statistical process that produces a regression line or a trend line, however you want to call it, basically a line that gives you the best description of that data. It goes as close as it possibly can to as many of the results as possible. Now, clearly, there's quite a wide spread either side of that, but we'll come back to that shortly. So the idea is you have an individual, they have a particular individual score, and as you can see from that, they might get one of 3 grades. So they're most likely to get one of 3 grades. But their actual predicted, or as I prefer, projected grade would sort of be the one in the middle there, where their score meets the regression line. Now, as I sort of intimated before, if your data is scattered everywhere, like the chart sort of on the top left there, there is no correlation. There is no relationship in that chart between the horizontal axis, which is the baseline score, and the vertical axis, which is maybe, it's actually a reading age on that chart. I've borrowed these from Chem just to illustrate. But in that scatter there is no correlation whatsoever. The one on the right has a slightly tighter correlation, 0.7, something like that. And then the little chart across the bottom there is giving you an indication of what 1, 0.8, and 0.4 would look like. So what does it look like in reality? Well, here's a real chart for GCSE music in a particular year. I can't remember which year. The reason the line sort of bends over towards the top is because I'm using independent school data here, the fee-paying schools in the UK. That's the chart I happen to have to hand, and they don't use linear fits. They use a slightly more what we might call curvilinear or you know, offline fit like that. So there's what music looked like in that particular year, and it just fades to show you what mathematics looks like in that particular year as well. So you can see that distributions do look different for different subjects, and the correlation, as it's called, gives you an idea of how tight the data is around that trend line. And correlations typically 0.5, 0.6 are way good enough, and that's the sort of thing that you get with most of the Chem fits. Now, just a sort of slight segue into another area, just for a second, while we're talking about this, because as I've suggested, when you look at different subjects, that spread of data either side varies. So, how are you going to make fair comparisons between subjects? Well, this is where again Chem does some statistical magic. You have to make a comparison. Sensible comparison between subjects, the spread of data either side of that line needs to be the same. And this is what's called the standardized residuals. We're going to be talking a lot about standardization as this presentation develops, but not going to go into the detail of how that's done now. But this is what is meant by the standardized residuals in Chem data. The standardized residuals means that chart has been statistically massaged, but the spread either side of the line is the same for each subject. Each subject is moved, as it were, to a different extent, but then it means that sensible comparisons can be made. The standardized residuals have a mean of 0 and a standard deviation of 1. I hope you're familiar with the idea of what a residual is, but just to very quickly fill that in case you're not sure, a residual is the difference between the grade that you projected or predicted based on the baseline score and what they actually did. So if we use a 9-to-1 scale for results like we do currently in the UK, if we predicted that a particular pupil based on their score would get something like 7.2, well, they can't actually get 7.2, but that's what the prediction comes out like. They actually got 7, they got a grade 7, then their residual would be 0.2, would be positive 0.2. If they got a 6, their residual would be negative. And what we're saying is once you standardize the results, then the data points with a positive residual is the same as, not the same number, but the average residual either side of the trend line is 0, and the standard deviation, the spread, is 1. These residuals don't have any units, and we've actually broken the link, the direct link between the size of the residual and the grade. A standard residual of 1 is about 0.8 to 1.2 grades, depending on the subject. But that's what the standard residuals are. Let's move on. So there's the basic idea about why the Chem data was set up, this research project, as it were, into what's now called value added. But actually, I have a sort of, what I think is a slightly controversial view. Maybe you just basically agree with me. But I think the actual value added data that Chem provides to schools is in many ways the least important bit that they actually provide. I think the individual pupil results, pupil records, this skill profile of the individual pupil that you get as a result of this, these are crucially important. I'll explain why shortly. We do get baselined GCSE or A-level predictions, but I think, again, they are things that you shouldn't focus in on. I think that these other instruments, what are called chances graphs, much though I hate that term, are crucially important in the process, because I believe the chances graphs are what you should be using to set your target or challenge grades, whatever the phrase you use in your school are. Because I believe that well used, carefully used, these can help to raise aspirations. And also you get the value added. But my view is that if you've got your teaching and learning functioning in your school, and of course we all have, but we always strive to improve our teaching and learning, our basic processes, our target setting and monitoring, if all that is functioning well within your school, then ultimately the value added will take care of itself. The more important thing is not to focus on what the value added is, it's to focus on how you get your processes in the school working and how Chem data helps you do that, and then the value added will take care of itself. So here's an individual pupil record, the sort of thing that you get back having done the baseline score with your pupils. I'm sure you're all very familiar with what this tells you. You've got your overall mid-year score in this case here, which is made of a seasoned mix of the vocabulary and the maths scores, because that forms what's been shown to be the best predictor of ultimate outcome. But the other skills you've got there, the non-verbal, etc., are very, very useful for you to see. These things are what are called the 95% confidence bands. In other words, if the pupils were to keep on retaking the test time after time after time, then their results would all lie somewhere within the line there. That particular result is the little diamond shape in the middle, but we're saying that we are 95% confident, or at least if they were to keep taking the test 95% of the time, the result might be different, but it would lie within that range there. So we see on that basis that for this particular student, the ones I've outlined in green are all very compatible. They all overlap nicely. But those two look, at least prima facie, as if they're incompatible. We've got some sort of difference here between vocabulary and maths. That may be an indication of a dyscalculia or something like that, something else, some educational lead perhaps that lies with that particular pupil and maybe needs looking into a bit further. Certainly when we got our batch of IPRs for our new fresh-faced year 7s early on in the year, I would sit down with my head of educational support and we would go through all the IPRs looking for any patterns like this, basically just by flicking through them, that stood out to us. But we certainly wouldn't be using this in any diagnostic sense. We would say this was just an early indicator, might be a pupil we need to keep an eye on. We might talk to the teachers about them. And in the end, if enough evidence of different sorts built up, then maybe we might take it a little further, recommend some sort of diagnostic test. But certainly what we've got here, and I think it's useful for teachers to have access to these, is an indication of relative strengths that can be exploited or supported within a class. It's just more information that you get to know about your pupils. And therein lies, I think, what it's really important. Not so much a focus on numbers, but really a start of a conversation. How well do we know our pupils? Is this telling us something else about our pupils which is useful to know? Any information is good information. It helps us to tailor the way we approach things in the classroom. But the crucial aspect of this is it starts the conversation about the pupil. I say that we focus on what the data triggers, not so much the data in itself. Data is useful, but it's how you use it that's the crucial part. Conversations. Most pupils, there's nothing that much to say. We get a spread of their abilities. Yep, that's pretty much matches what we see in the classroom. Oh, there's a bit of a distinction here. I didn't know that pupil was particularly strong mathematically. I didn't know that pupil, their vocabulary score was a bit low. Well, yes, now I think about it, that does match up things I've observed in the classroom. The conversation, as I said. So that's the use of the baseline data. But moving on, we were talking about grades. And one of the things, obviously, that comes hand in hand with the baseline data are the mid-year predictions. Hopefully, many of you have seen them, these spreadsheets that we get where we have the pupils in rows and then columns across all the possible GCSEs or public examinations that you might have, through from English language to underwater basket weaving, seemingly, with predicted grades for each one. It's a single simple grade for a subject that lines up with a particular pupil. But I think that's too simplistic. It's something that in my time, I've sent out these spreadsheets to my heads of departments, heads of faculty, as an academic head. So yeah, stick up my hand. We've encouraged this apparent focus on this single simple grade. And I can understand teachers sort of picking up with this. They want to avoid, to whatever extent possible, any admin bureaucracy. And why shouldn't they? We should be trying to minimize that for them as much as we possibly can. And it sort of takes on almost the status of a kite mark for a pupil. Oh yes, Midges says that you're a grade 7 pupil. Dunk. That's what you're going to achieve. And in some instances, I think the teachers have a view that this is what their teaching will be judged on. This is the value added side of it. We did a whole presentation last year about how you convert your data doubters. And one of the key aspects of this, I think, is to take the heat out of the whole value added thing. You walk the walk of this basic idea that the value added will take care of itself if the other systems are in place, if teaching is good, if learning is good, if everything else is functioning well within the school, let the value added take care of itself. You want to decouple this idea of what this grade is from judgment on teaching, because we are trying to encourage our teachers in the setting of this grade, this challenge grade ultimately, to be aspirational for their pupils. And this single simple grade that churns out of the statistics is not necessarily the best thing for the pupil. If we present it to them, how do they relate to it? Where does it come from? Yes, they sat a test in some dank corner of the school in front of a computer screen at some point in the past. And now apparently they've been embossed with this grade which has come out of the statistics. What does that mean for them? It's another judgment on them, a little bit like teachers may be slightly afraid of a judgment in terms of the quality of their teaching here. So I think this whole idea of using the raw prediction, which is, you know, the baseline score goes up, meets the trend line, comes across, that is statistically on average what a pupil with that mid-year score will tend to get. I think it's a flawed process to try and use that in the context of developing aspirational challenge grades for our pupils. Firstly, it's not a prediction. It's more like a projection, as I said. And I think terminology matters in this process. When you're trying to present this to pupils, when you're trying to present it to parents, when you're trying to present it to your colleagues, this is not predicting. This is what will happen. It's a projection. This is a trend. This is what we think someone of your ability, on average, will tend to get. But sometimes it's not ambitious enough. Maybe, again, there's a tendency for teachers, because the process we tend to go through is we put these grades out there and say, what do you think? What grade should the pupil have? There's some sort of tend to be slightly conservative. Maybe a genuine reason why the data doesn't apply to that particular pupil. Maybe they had an off day during the mid-year test. Maybe they didn't treat it that seriously. I think we need something a little bit more nuanced than just this single kite-marked grade. And this is where these, in my view, very badly named chances graphs come in. And here's a spread of chances graphs just for a segment of subjects, all for a particular pupil with the same mid-year score. Well, it's an individual pupil. It obviously has the same mid-year score. The point I'm making is that the chances graph for each subject here is based on the same mid-year score. And here we've got much more information. Like I said, this is a more nuanced thing to be approaching the whole process of setting an aspirational grade with. It needs to be handled carefully. All data of this sort needs to be handled carefully, obviously. And in particular, we've got to get away from this implied idea from the title that this is chance. You know, if we look at the biology chances graph on the screen there, we can see that 29% of the pupils got a grade 9, 22% got an 8, 22% got a 7. They went into the exam, they threw the dice, and bang, they landed on a 9. Well done. It's not chance. Neither is it ability. These are all the same mid-year scores. So the 29% who got a 9 with the same ability as the 8% who got a 5. What is the difference? What has made the difference between those grades? So I've never come up with a particularly sensible title for these, which is partly why my one-man campaign to get Chem to change the name hasn't worked terribly well, because I haven't got a good alternative. Potential performance indicator is the best to come up with. I'd welcome any suggestions. Where do these graphs actually come from? We need to just look at that before we develop the thinking any further. And I take you back to this chart here. There's my scatter of results. There's my shaded region that shows you where most of the data lies. And there's my trend line running through. But what I want you to think of is that this has a sort of 3D aspect to it. It's coming out of the page at you, because if I'm going to get all my data on there, those little diamond shapes have got to have a height, because there's going to be loads of pupils with the same score all stacked up on one another. So if you think of that thing as having a height, and there is the line that gives you the prediction somewhere between 6 and 7 here. But if instead of doing that, I did my same line at that baseline score, and did a vertical slice through that 3D chart there, then it might look something like that, where the height of it was the number of pupils that had that particular mark, that particular outcome grade. Converted it to a percentage, you get something that looks like that. And that, I want to suggest to you, is where this chances graph actually comes from. And there's one for chemistry with a mid-year score of 118. That's a band A, very able pupil, clearly. And you can see that 26% of pupils with that baseline score in that year went on to get a grade 9. Which means that 74% didn't. So if you free up the time, that's a whole process in itself, I know, not something we can easily go into today. But if you can free up the time to have a conversation with the pupil about this, then there's something to be said here. you can approach this, look, all the candidates in this chart had the same baseline ability. All grades are possible, encouraging voice. All grades are possible, pick your socks up slightly voice. Just because you're an able pupil with a score of 118 doesn't mean you're going to get the 9, because 74% of pupils with the same ability as you didn't. Right, at the minute you're sitting on a 6, somewhere between a 6 and a 7. But look, 21% got an 8, 26% got a 9. You have the ability to get a top score. We're trying to be aspirational about our pupils here. Here's the same pupil, different subject. So you can see how the chances graph varies depending on what the particular subject is. Here's an example to make the point further. Actually pluck this from A level rather than GCSE, but it just makes my particular point. What we've got here is 2 subjects, art and design and drama and theatre. The top row is art and design, the bottom row is drama and theatre. And you can see that the prediction for art and design was a B, and the prediction for drama was a C. Because this is A level, we've got 2 charts for each subject. One is based on the GCSE, average GCSE score. The one is based on the adaptive test. The left-hand columns are average GCSE scores. The right-hand columns are adaptive tests. What do we glean from looking at this? The raw prediction is oversimplistic. Yeah. If you look at drama, then maybe the prediction is actually reasonable. But if you look at art and design, then are we being ambitious enough for that pupil? We're saying we're projecting you to get a B, but actually 27% of the pupils, based on GCSE score, got better than that. You don't see this spread if you just focus on a single grade. The information here, you'd look at the grade and you'd say B for drama, sorry, C for drama, B for art and design. Look at those charts and you're seeing a rather different story. More information in there, needs to be handled delicately, but you're beginning to see possibilities that you wouldn't otherwise see if you simply focused on that kite mark grade. Oh, and by the way, for this particular one, which I picked to point in another presentation, look at the difference, particularly for art and design, between the GCSE score and the adaptive test score. Look at the A and A star columns under adaptive test compared to GCSE. What is this telling us about this particular pupil? To me, that's an indication that this particular pupil may well have underperformed compared to their baseline ability as measured by the adaptive test. They may have underperformed at GCSE. So the GCSE, as a predictor of A-level performance, is giving them a lower prediction, a lower spread than the adaptive test. That's a different subject for a different time, but it's interesting. So as I've been intimating, I think terminology matters here. We need to be talking about projections, not predictions. We need to be talking about potential performance indicators, or some better name, not chances graphs. And we're setting our challenge grade, this aspirational grade, which we're saying to our pupils, you are able, you have ability range to be performing at this level. Come on, we can do this together. Are you going to rise to the challenge? But simply saying that in an ideal world, that challenge grade would be set by some sort of negotiation. They need to buy into it as well. So I think there is a value in trying to find the time, cutting down on reporting, cutting down perhaps on different processes that our teachers do in order to free up the time to allow them to have these conversations with their pupils, which with most pupils is a very, very quick thing indeed. So you've set this challenge grade using the information coming from the chances graphs. That doesn't guarantee that the pupil is going to get it, of course not. The teaching, the learning needs to be in place, the focus on exam technique, all of those sorts of things. But we do need to monitor and revise that grade and monitor and keep an eye on progress as we're going along. Yay, testing. There is a role here for testing. Whether it be the slightly informal in-class test or the more formal, maybe across cohort, end of year, end of topic, end of key stage test, however it is. So let's reflect just for a minute on why it is that we do actually test. Well, I have to confess, having been on both sides of this as a classroom teacher working at the chalk face and also as an academic deputy, then I do sometimes think that we test simply to fill the mark book, but let's move on from that. I sometimes think our colleagues think that we test mostly to make the academic deputy happy, which is a very good and virtuous thing in its own right, but I don't think we necessarily want to make that a key aspect of our policy. What we're talking really here is about student opportunity. And I know personally, this is slightly off topic, but I think it's important nevertheless. I know personally, I used to argue quite strenuously for having proper mock examinations, not because I was that particularly interested in the results, but because I think that revision is a skill and pupils need the opportunity to practice that skill. We need to give them that opportunity by having sensible mock examinations and end of year tests, that sort of thing. And we need to make that point that revision is a skill. I used to go mad whenever pupils said to me, oh, I just thought I'd do the exam without doing any revision to see how well I did. You have missed the point. Anyway, that's a hobby horse. Move on. Developing exam skill by actually sitting in an exam context. I think that is extremely important aspect of this. But clearly, gauging progress, gauging understanding is key. All of these things come together to help us raise our standards. Informing parents and pupils, that is also a key aspect of this, and clearly the information goes into tracking our progress. We've set a particular pupil, a particular aspirational challenge grade. We've seen a row of tests coming along there. They're not quite making it. What do we need to do? What interventions do we need to make? This pupil's knocking it out of the park. They're doing much better in the tests. Okay, then, well, let's say have another conversation. Do we need to raise their challenge grade? So if we're going to achieve all of that, what is the best process by which to do it? What is it that makes a good test? Well, I know, yeah, something that's easy to mark, maybe, yes, but a test, if it's going to be a good test, needs to be reliable. Hopefully, if a group of students take the same test on multiple occasions, they get pretty much the same result. It needs to be discriminatory in a good way. In other words, it needs to separate out the least able from the most able in a sensible way. It needs to have the right level of difficulty. These two are clearly coupled. There needs to be something in there for the least able. There needs to be something in there to stretch the most able. And yeah, it needs to be relatively easy to mark. Okay, so how does that look in terms of a distribution of marks? Well, here's a mock-up, obviously, and don't get me wrong, a lot of what I'm saying here, you know, quite often we have a limited number of pupils taking a test, 10, 15, 20, 30. So the chart's not going to look as smooth like this because, you know, this is based on hundreds going into a particular test, so, or into a particular distribution. So yes, we accept that. These are illustrative. Here we've got a particular test, which I think is too difficult. The average mark appears to be 20, and it's not discriminating. That spread, the whole thing is sort of squashed between something like 12 or 15 and something like 27, 25, 27, something like that. Here's a test that's too easy, but not discriminating. Here's a test that looks just right. It's got an average roughly with 50%, and it's got a nice wide spread of results. That's discriminating in the way I've intimated. We refer to the average sometimes, or the average as the mean, but this spread is what we refer to as the standard deviation. Many of you may know this already. Forgive me for belating the point, but I'm going to use the terminology, so I thought we ought to be clear about what it was. That's our standard deviation, and roughly 34% of the population lie within that region there. Okay, so here is some test results. I've got some rows of pupils, named A through J, and I've got some marks for English, maths, science, and languages tests. The English mark is out of 40, the maths mark is out of 70, the science mark is out of 80, and the languages mark is out of 60. So already we have some degree of confusion here. And you can see that A got 21 out of 40 in English, he got 24 out of 70 in maths, 54 out of 80 in science, 33 out of 60 in languages. Well, how well has he done in each one? What comparison can we possibly make? Well, let's make a percentage so that 21 is 53%, 24 is 35%, 54 is 68%, etc., etc., etc. But again, I'm suggesting to you, we're still not really seeing how well the pupil did, because out of all the results there on that table, in English, the average, the mean was 69, and that spread, the standard deviation was 19. In maths, the mean was 35, the standard deviation was 2, etc., etc. Let's look and see what these will look like if they were part of a broader distribution. Much more marks in there. That's what the English would look like. What I actually did here is I created that distribution and then plucked the marks out of it. That's what the maths one would look like. This is what the science one would look like. And that's what the languages one would look like. Yeah. Now, you may have noticed that some of the marks I've highlighted in red and orange in the background here, and a new row, 1 sig plus and 1 sig minus has appeared. Let me just quickly explain what I mean by that. What I've done there is I've take the English one. What I've done there is I've taken the average, the mean, 69, and I've added the standard deviation on, 88. And any pupil that scored higher than 88, I've coloured in red. They have done better than that mark. And I've done sig minus, take the mean and knock 19 off to give me 50, and I've covered them in orange. And if you look across the subjects, I've done the same thing. And the different pupils are coloured in differently. They're telling us that the pupil did particularly well in English, maybe, particularly well in science, particularly well in languages. But I'm saying that the comparison isn't easy to make because of those different distributions of marks. We're seeing here that the different tests were different types of test. There were different standards of test, and it's making our comparisons difficult. How are we going to help our students to develop in this sort of context when it's very difficult to see how well they did? Well, what I'm suggesting is that what we ought to be doing is standardizing our percentages. Here are the same marks again, but I've introduced an extra column now, the ST percentage column. For each one of these tests, I've converted the marks so that they now all have the same average, the same mean, and the same standard deviation. Yeah, that column is showing us a percentage. It's out of 100, but the average is now 50 and the standard deviation is now 12. Yeah, and those same colors are left in the background. So those are the ones I picked out before. They're still colored there in the background. Now, look at this. What I've done here is I've shaded in some pupils that ended up with the same standardized percentage. So in orange, we've got all the pupils that ended up with the standardized percentage of 49. Look at how different the raw percentages were. Pick out the standard percentage of 40. Look at how different the raw percentages were. Pick out the standardized percentage of 68. Look at how different the raw percentages were. all the pupils that got, say, 68 standardized percent really did as well on each of those subjects. But you wouldn't necessarily have seen that even from the raw percentage, and you certainly, I suggest, wouldn't have seen it from the raw mark. So why should we bother actually doing this? It looks like a bit of a faff to do it. I think we should be doing it because it does form a valid performance comparison. I think in the end, it needs to be handled a bit carefully, less confusing if we report on this information for parents and pupils. There is a big sort of hurdle to overcome here, which is, your pupil gets their paper back and they get 17 out of 20. So they type 17 divided by 20 times 100, at least if they know how to calculate percentages, and they get their percentage and they say, yay, that's the percentage they've got. Then they're actually told, no, it isn't the percentage that they've got. How do you break that link between the mark on the page and the percentage that they actually get? Well, ultimately, I think what you do is that you actually report a grade, not a percentage, not a standardized percentage. You use those standardized percentages to create grade boundaries, and then they can be the same grade boundaries across all subjects because you've used a standardized percentage. So an A means the same thing in each subject, and that's what gets reported back. And then valid comparisons can be made. It allows heads of department, you allow heads of department to tinker with those grade boundaries within bounds. You sort of say as an academic deputy, this is what we think the grade boundaries should look like across all subjects. You allow them a certain degree of tinkering, but not so much that this ability to compare across subjects is lost. Clearly, some subjects have a different number of pupils taking them, so the statistical process of standardizing is not as accurate in each case. If you've got a subject, a minority subject with only about 10 or 15 pupils taking it, if you've got a majority subject with 100 odd pupils taking it, the statistical process is not as good for the minority subject. Yes, of course, that's why you allow the HODs to tinker, but not so they give all the pupils A's or something ridiculous like that. Sensible comparisons still need to be made across subjects. But now, tutors and heads of year, if they're sort of seeing the results of their charges across all their subjects, they can be seeing A, B, A's, whatever, across the subjects. They know that those grades mean the same thing in each subject. They can be starting to see patterns. They can be seeing progress. Is this pupil always tending to do a little bit worse in subjects that have some mathematical component to them? Maybe we need to support their math skills. Or are they doing really well in history and geography, but not so well in English? Why should that be different? We see these patterns because we're seeing valid, more accessible comparisons between the subjects. And that allows us to do things that we wouldn't otherwise do. How do we do this standardization? Well, if you're not that mathematically inclined, of course, nothing wrong with that, but just a quick talk as to how you actually do it. I mean, if you have a spreadsheet ninja on hand in the school, then I'm sure they can set this spreadsheet up for you very, very easily. I'd set one up where the teachers just simply type in their marks on one side and the standardized grade came out straightforwardly for them on the other. They didn't have to do any work on this. But how do you actually do it? Here's a distribution that has some sort of an average, mean M, and some sort of standard deviation S. What you do is you take each value and you subtract M from it. So your average is 57. You subtract 57 from each value. Clearly that makes some of them negative. So now you have a distribution that's about 0. And what you do is you divide each one by the standard deviation. So now you have a distribution which is spread around 0 and it has a standard distribution of 1. What you do then is you multiply by the standard deviation that you want. So it spreads the results out again, but it spreads them out to the extent that you want. And then you add in the mean that you want. And so it shifted the whole thing now to a distribution which has the mean that you want and the standard deviation that you want. This can be slotted into a spreadsheet very, very easily. And that then gives you your standardized test scores. like I say, very, very important. The process doesn't work very, very accurately if you've got a limited number of pupils, of course, but it gives you an indicator and you give a certain degree of freedom to adjust the ultimate grade. But by and large, it's a worthy process to be doing because it allows these comparisons, as I said. Well, maybe you think this is going a little bit too far, that you're not thinking that the effort required to create these standardizations is worth it in the end. I could debate that point with you because I think we certainly made a lot more progress forward once we started reporting standardized grades home to parents and pupils, and also discussing them within the context of progress, because it does even out the fact that tests, you know, we're not experts on test settings within school. You can't make tests equal standard. And in particular, for end of year exams, that sort of thing, this was a very worthy thing to be doing because it did allow us a more robust tracking and monitoring. If you think this is a step too far, the next thing I'm going to suggest will be a step too far for you. But just sit back and think for a minute and see what I'm going to suggest. Because what I'm going to suggest is this. If we're going to go to the trouble of standardizing our tests so that they have the same mean and standard deviation, then why not standardize it to the mean and the standard deviation for your mid-year results for that particular year group? Here's a selection of year 7 pupils. The ones on the screen there in that chart, their mid-year score average was 98, and their mid-year score standard deviation was 8.47. So why not standardize our test scores so they have the same mean and standard deviation? Now, that's clearly not a percentage anymore, but it is a sort of mid-year mark. And then we can compare that to what they actually got on the baseline test. But we can go further because we can use that regression line to generate our grade for us. And that is a very valid comparison to our challenge grade, because that takes into account what you might call the difficulty of the subject. Bear with me. This is what I'm saying. Here's our scatter again. There's our most region. There's our regression line. Now, basically, again, there's a little bit of mathematics in here. I know we're not all mathematically inclined, but basically the idea is that that line is characterized by two numbers, A and B. So that when we go through this process of producing a grade for our pupil, and I know I don't like these predictions as much, but bear with me. We're basically saying you take the mid-year score, you multiply it by A, and you add B, and that's what gives you the value, where A and B are subject dependent, and you can look them up. Chem have very helpfully produced tables of these things. So here we are, I've done it. There's my pupils again. And again, here are my test results. So I've now got the same marks, the same percentage, but now I've standardized, not to a standardized percentage, but I've standardized to a mid-year score. So that column all has the same mean and standard deviation, 98 and 8.47. And you can see along the row A and B, I've plugged in to a ridiculous number of decimal places the actual values of A and B as provided to me by my friends at the Chem Centre. So for English, the A value was about 0.08 and the B was about -3.2. So what I've done is I've taken that score of 91, say, for pupil A, I've multiplied it by A and added B, and that's 4.5. That's their 9-to-1 equivalent GCSE grade based on that test. And now I've highlighted pupils here, and you can see what a different set of actual grades we're getting out. These are the same pupils I highlighted initially. So 53%, 21 out of 40 in English got you a 4.5. 35%, 24 out of 70 in maths got you a 5. 54 out of 80 in science got you a 4.6. That's for pupil A, and you can see with G, and you can see with the ones outlined in red again here. Just leave that for a moment to let you just have a look and absorb what I'm saying here. I'm saying that even if we look at the ones with the same baseline equivalent, I'm sorry, I probably haven't made this very clear. The ones outlined in a lightish red box, you can see their baseline equivalent score is 97. Okay, so look at J in English, 27 out of 40, that was 67%. The baseline equivalent score is 97, the grade is 5.1. Now switch your attention to A, 24 out of 70 in maths, baseline equivalent 97 again, the grade is 5. 97 again in science, 4.6. 97 again in languages, 4.6. So we're getting GCSE grade outcomes here. We round up, obviously, if we're reporting this. And we've gone from our raw mark right across to a GCSE grade, which can be compared validly with the challenge grade that we've set, because we've corrected for the standard of the test, and we've corrected for the standard of the subject, the inherent difficulty of the subject, using the Chem statistics. What's the moral of the tale? I'm running a bit short of time. I apologize, I've taken a bit too long in certain areas. I believe baseline data informs you about the pupils. It starts conversations about the pupils. It's an early indicator of educational needs, where we might have interventions or indeed stretching if we're seeing that the pupil is really able. I think the projection data used appropriately, particularly with the chances graphs, motivates, encourages, warns in certain contexts, raises aspirations. I believe that testing and monitoring, particularly if we report in a valid way, that gives us the ability to compare with these challenge grades together, form a good path for progress, ultimately leading to raising the standards of our public examination results, which is good for us as schools and certainly good for the pupils who are our output. Thank you very much indeed. I'm sorry I've taken 2 or 3 minutes longer than I intended to, but pass back to the people in charge.
Thank you very much, Jonathan. This has been a really useful and insightful presentation. Just a reminder about questions. If you've got any questions for Jonathan, please post these in the questions box. So I'm really delighted to share that we've got a couple already. One of which is there a recommended way for schools to develop their own predictions for subjects that Chem could not provide any prediction data for because of the insufficient sample data?
Well, that's an interesting question, isn't it? Because if the sample data is insufficient for Chem to produce it, how valid can the data you produce within your own school be? Certainly, there is nothing to stop you taking things like looking at your baseline test results, looking at your mock examination results and charting those and seeing what correlation there is between the one and the other. You need to go back over several years, 5 years minimum, I would say, to get any decent statistical weight behind a comparison of that sort. But you can do it. There's nothing to stop you doing it. And get some sort of a line out of that, which you could use as a basis for starting to do some projections in that regard. It's all perfectly possible. And you can hone it as actual GCSE results come in. The slight problem we've got at the minute, clearly, is looking back over 5 years of consistent data where nothing changes, like the grading system that we use at GCSE, the standardization that Chem uses for the baseline data, The last 5 years have been a little rocky, shall we say, with regard to that. But in principle, it could be done. If your school doesn't have anyone with sufficient statistical or data confidence to do that, then I'm sure that Ken could find you somebody, perhaps like myself, to do it for you. But simply because the statistics are going to be based on a small sample of pupils, then you'd be taking any outcome with a salt cellar, not with a pinch. But it's better than nothing, certainly. And I would be starting off by looking at charting my baseline scores against mock examination or end of year results into a chart, stick 5 years worth of data in there, and just look and see what the pattern looks like. Is it a complete scatter all over the show, as I fear it may be, because pupils don't necessarily take mock examinations that seriously, at least in my experience they don't, or if there is any sort of grouping of the scatter which might indicate that some sensible line could be drawn. I mean, even if you just draw it by hand with a ruler, I think you need to look and see what your data looks like. That's a perfectly sensible, a perfectly valid thing to do. I just fear I'm not that confident about whether you'll get anything that looks at all reasonable at the other end.
Thank you, Jonathan. Another question here. Do you have any suggestions for how to approach discussing baseline scores with pupils which are very low, and the same with the chances graphs? This is a really sensitive area and not particularly widely used in Scotland.
Yes, that's a very, very interesting question, isn't it? I have some suggestions. I think knowing the individuals concerned is the overriding thing in this, but my suggestions would be along the following lines. I often feel that sharing the exact values of scores isn't necessarily the best way forward. I sometimes think that sharing the exact values, the midget score of 107 or 104 or 105, whatever it is, even with teachers, isn't necessarily the most helpful thing for them. I was toying with the idea of color coding it, maybe, or using a symbol. So if this particular pupil was slightly above average, rather than giving a score, you just put plus next to the midges. Or if they're well above average, it's plus plus. If they were average, it was just like a 0 or something, some symbol. If they were slightly below average, minus. If they were quite a lot below average, then minus, minus. So you could try taking the sting out of it by not using actual numerical values. You could say things like, your score is somewhat below average. That's that sort of thing. You can also take the sting out of it by saying, this is just one day and one test. So, you know, perhaps you didn't perform that well on that particular test, but it does slightly fit in with this other information that we've got coming out of the classroom. So it does form part of a wider picture. And indeed, with the chances graphs, then it's the same idea. This chances graph is based on your score that you achieved on one particular test. This is what it says. How do you feel about that? It isn't saying this is what you absolutely will get. It's saying that projected forward, pupils with this sort of score tended to do this. We can turn that situation around. You're not, in that phrase, kite marked to get this score. We're going to be behind you on this. We're going to be helping you. We're going to be supporting you. Let's turn it around. Let's not say that you are doomed, as it were, to get this low outcome grade just because you had a particular test at a particular time in the past. But we do need to be aware that it's going to take a little bit of work on all parties' parts to get you to where you need to be or where you want to be. Those are the sorts of approaches I would take. Some quick suggestions. I do think that taking the numerical value out of it and just referring it to average, below average, or whatever, is a good way forward. It stops people getting hung up too much on the difference between 107 and 106, which are the same thing, basically. But yeah, no, it's a difficult one. It's a very sensitive area. I'm not sure I've got any particular magic wand to wave on that one. In fact, I'm sure I haven't. But those are the starting points I would certainly approach it from. I don't know if that helps at all.
Thank you, Jonathan. I've got a similar question here. So the yellowest number, someone said the yellowest number is never revealed to students and parents for obvious reasons in my school. What is your experience when you've done this in the past, when it is revealed and discussed, and have parents used this data in a kind of in a negative way post-exam results?
Certainly at institutions where I've worked, we haven't. Well, that's not true. At some of the institutions I've worked, we hadn't routinely shared the scores with parents. That's true. However, certainly the feeling is with data regulations and data legislation around the place that the parents were well entitled to ask for it, and you'd have a hard time not revealing it if asked for it. So you sort of take the bull by the horns and share it out. We used to have a presentation evening. We used to have a presentation just before the Year 7 parents meeting, where we talk through what the Chem data was and then share it directly out with the parents. I come more to the view now that a color-coded thing, you know, green, average, amber, whatever, or plus, but rather than actual specific numbers, just saying where they fell in the pattern, I would certainly send out IPRs rather than just simply raw numbers, so you got a better picture that there was a range of scores indicative there. I would certainly be doing that if I was sharing it with the parents, and I do believe that one ought to be sharing it with the parents. It's just that in the institutions where I worked, that wasn't something that we got round to doing before I left being an academic deputy head to be a data consultant, and then obviously when all the data regulations came in. Have we had, in my experience, have we had a situation where parents have phoned in after exam results? Actually, no, the other way round. We've had situations where parents have come in after examination results and said, you know, why haven't they got the grades, etc., etc. And we've been able to point to the challenge grade. We've been able to point to the baseline data, the projections. We've been able to point to the record of where they were scoring in their tests, etc., and say, based on all of this evidence, your son/daughter actually got the grade they were always heading for, and actually we warned you that they might well be heading for. You know, we did what we could. I'm sorry, but you know, this is the evidence to suggest that actually they got what they got, that we sort of what we felt that they were heading for. So no, the only experience I've had has been cases where actually it's come to our aid in defending the outcome rather than the opposite way around. That's my personal experience.
Fantastic. Thank you, Jonathan. Aware of time, but there's just one more question here that I'd like to ask you, which is there a risk that any identification of pupil ability becomes very deterministic, having a negative impact on expectations and undermining a growth mindset?
There is always that risk, which is why I believe, which is why partly I follow this, let's not focus in on the value added, which I think is a particular contributor to that in schools that I've experienced. But I think I'm floundering slightly. I think that focusing on this idea that the raw data, the baseline score, generates conversations about the pupil, and if the conversations are positive and supportive, etc., then the fact that the data itself oughtn't to be. It's the conversations that arise as a result of the data. And clearly, you know, if the data looks poor, then those conversations start off slightly with a particular emotional tone. But it is the conversations along the lines of supportive here. This is an indicator. It's not a cast in stone. This is not saying what you are, because we all know that, you know, there are in certain subjects, for example, arguably more creative subjects, the data doesn't have the same level of validity. That's something we discussed in a previous webinar. So I do believe there are ways to approach it that mean you can be supportive, you can be growth-minded, because after all, this is just one indicator taken on one particular day. And that's very important to continue emphasizing. It is the conversations that matter the most, not the data itself. And I think that we possibly encourage an over-reliance on the raw data by talking about predictions, by talking about the single grades rather than using chances graphs, because for any score, a range of results is possible. For any score, a range of results is possible. So those are the approaches I would use to emphasize the growth aspect of it and minimize the sort of restricted nature of it.
Fantastic. Thank you, Jonathan. I think we're out of time now. So any questions that we haven't been able to answer, we'll get back to you after this webinar. I've just got a quick reminder here. You will all receive a certificate of attendance via email 1 hour after the webinar finishes. You'll also receive an email from me early next week containing the link to watch the webinar recording on the Chem website. And I just want to take some time quickly just to say a huge thanks again, Jonathan, for your presentation, but also a huge thanks to you all for tuning in today as well. So I'm going to hand over to Jonathan quickly for the final comments before we end the webinar.
Just to support that, really, thank you very much for giving me your time and attention. I hope it's proven useful, controversial possibly, but I hope I've made a case. You may want to stop somewhere along the journey I've outlined, but I've made a case for what I believe from my personal experience is a useful process to do. Overriding thing at the minute, clearly, everyone, please stay safe, stay well, and good luck to you in the current school context.